The next set of results, as you can see, are called the t results. And t simply stands for tan of, well, it says theta on 2, but again, I tend to think of it as half the angle. So then again, you can use it for other things rather than just theta and theta on 2. Now remember, we've got a double angle result that said yesterday that tan 2 theta was 2 tan theta on 1 minus tan squared theta. That's basically it right there. It's a double angle result. But instead of using 2 theta and theta, I'm using theta and a half theta. Okay? But I can tidy that up now, because if I'm saying, oh, t is going to represent tan half of theta, then tan theta becomes 2t on 1 minus t squared. That's our t result for tan. Now we can draw our triangle. Opposite over adjacent, 2t over 1 minus t squared. A little bit of Pythagoras and a whole heap of algebra. We can find the hypotenuse eventually. There it is. T squared plus 1, or 1 plus t squared, however you want to say it. So from that we can now read off the t result for our other two. If t is tan theta on 2, tan theta is 2t on 1 minus t squared. Sine theta will then be 2t on 1 plus t squared. And cos will be 1 minus t squared on 1 plus t squared. Note, if t happens to be tan theta, then tan 2 theta is 2t on 1 minus t squared. And if t is tan 2 theta, then tan 4 theta, double the angle, 2t on 1 minus t squared, and so on and so on and so on. But the vast majority of cases we use tan theta on 2. All right. We're going to show that 1 minus cos x on sin x is simply t. Now, without the next words, this would be a silly question, because how on earth would you show 1 minus cos x on sin x is t? That's why where t is, need t to be defined, and there it is, tan x on 2. So we can use, because x is double x on 2, I can substitute in my t results for cos x and sin x. So cos x, there we go, we get 1 minus t squared and 1 plus t squared over 2t and 1 plus t squared. The nice thing about fractions that involve cos and sine, because they're both over the hypotenuse, the bottom of the fraction always turns out to be the same, cancels very nicely. So we can multiply top and bottom by 1 plus t squared, and I get 1 plus t squared minus all of 1 minus t squared over 2t. 2t squared over 2t, t. There's our answer. All right. So t's tan theta on 2, yet again. We're going to simplify 2 tan 75 on 1 plus tan squared 75. See, when you first see something like that, you think, oh yeah, double angle, 2 tan theta on 1. Oh, it's plus tan squared, not minus tan squared, which is the double angle result. So I can use the t result for this one. But what it means is t is going to represent tan 75. Because then, so in other words, theta on 2 is 75. Theta must be 150. So we now have 2t on 1 plus t squared, which is the t result for sine. In our problem, theta will be 150. So sine 150, second quadrant, sine's positive, 150, the acute angle is 30, sine 30, half. Ta-da! We're going to prove 1 plus sine theta minus cos theta on 1 plus sine theta plus cos theta is tan theta on 2. Again, we've got a situation where one angle is double the other. So I'm going to change everything into t results, because it's a lot easier sometimes to play with polynomials than the trig identities. So 1 plus sine theta minus cos theta would be 1 plus 2t on 1 plus t squared minus 1 minus t squared on 1 plus t squared. And then on the bottom, 1 plus 2t on 1 plus t squared plus 1 minus t. Again, the denominators are the same. I can multiply top and bottom by 1 plus t squared. And let's tidy up. The top I get 2t squared plus 2t. On the bottom I get 2 plus 2t. That factorises. T plus 1 will cancel. The 2's will cancel. What do you know? I'm just left with t again. That doesn't answer the question yet. because they didn't say in this case to prove it was equal to t. They said prove it was tan theta on 2. So now I say, oh, well, t is tan theta on 2. So there's our answer. 2005 HSC, they were very kind. They told you you're going to use your t result to solve this problem. So by making the substitution t equals tan theta on 2, although they did give you the otherwise option if for some insane reason you wish to do it another way, you can go and do it another way. But little hint here, if they suggest to do it one way, it's probably going to be the easiest way. Cosec theta plus cot theta, we're going to prove that's cot theta on 2. Okay, cosec plus, oh hang on, they're the reciprocal, so I'm not going to think my t results, but the reciprocal. Cosec is the reciprocal of sine. So it'll be 2t on 1 plus t squared, but upside down. Cot is the reciprocal of tan, so it will be 2t on 1 minus t squared, but upside down. Oh, that's nice, the denominator's the same, 2t. It's lovely how that works out. 2 on 2t, which is 1 on t. Well, t is tan theta on 2. 1 on t would be the reciprocal of tan theta on 2, and so there's our cot theta on 2. 2b, the type of pencil they suggest you use in the NAPLAN exam.